Right. In this video, we're gonna focus on questions and answers on calculus. Okay, now we have a question here, and the question said, given that 4s raised to 3 plus 2s squared y minus 6y squared is equal to minus 3s, find the differential coefficient of the function at the point 1 comma 1. Okay, now let's understand this question here. Now we're asked to find the differential coefficient. The word differential coefficient is the same as differentiation or derivatives. Please take notes. So we're asked to find the derivative of this particular function here. Now when you look into this function here consists of s and y in a given function. And whenever you see a function that consists of s and y in a particular function or in a particular equation, and you are asked to find dy dx, we use implicit. Okay, so it means that this particular function here is an implicit function. So how do we differentiate an implicit function? Class, before we solve this first, let's write solution. Right. Okay, now how do we differentiate an implicit function? But before we differentiate this, there's something I have to let us know here. Whenever you are asked to differentiate any equation, the first thing to do is to identify the function. Different functions have their different method of or different pattern of differentiating. Okay, so let's differentiate this function here. Okay, now we have this to be 4s raised to 3 4s raised to 3 plus 2s square y minus 6y squared is equal to minus 3s. Okay, now we are asked to find dy dx of this. We are asked to find the dy dx of this function, and we say that this function here is an implicit function because it consists of s and y. Okay, so what is an implicit function? The word implicit, the I means input, the M means multiple, the P means parameters. So the input of multiple parameters or variable in a function is called implicit. Please take note. So the dy dx of an implicit here, the short way to solve this, the hard trick to solve the dy dx will equal to class minus f prime of s over f prime of y. Okay, now let's understand this formula here before we solve the equation. Okay, now listen to me carefully. From the formula here, it means that for me to get this part here, I have to differentiate only for s. While for me to get this part here, the down part, the denominator part, I have to differentiate only for y. But whenever you are given an implicit function and you want to use this particular formula, okay, what you have to do is to take anything that is at the right hand side to the left hand side. Please take note. So let's make the equation to be in standard way. Making the equation to be in standard way, we have this to be 4s raised to 3 plus 2s square y minus 6y squared plus 3s is equal to 0. So this equation now is in a standard method. So we can now use this particular formula to solve this. Okay, let's use the formula here. That means dy dx is equal to minus, let's differentiate only for s. only for s is this. There is s here and there is s here. So let's differentiate this. I will have this to be 12s squared. So differentiate this part here. Only for s, I will have this to be 4sy. When you differentiate the s, you take the result of everything here. Okay, differentiate the s, you have 4s. Take the total result of what you have here to be 4sy. Please take note. So I will have plus, the plus is this sign here. Please take note. Plus 4sy. So now let's differentiate this guy here. Differentiate this, I will have plus 3. Okay, let's go back to the formula. For the formula here, we have gotten the first part, that is f prime of s. Now let's get the second part here, that is f prime of y. So it means that I have to differentiate only for y. So let's differentiate for y. But before we differentiate for y, let's identify all the y parts. So this is for y and this for y. Please take note. When you do that, we have something like this. When you do that, we have something like this: 2s squared. If you differentiate only for y, minus 12y. Please take note. When you differentiate only for y here, you have this will be 2s squared. So differentiate this y only, you have 1. So the total result will be 2s squared times 1 will give us 2s squared. But we are not only asked to find the y ds here, class. We are asked to find the y ds at a particular point. That is at this point here, class, at 1, 1. And what does it mean here? It means that the value of s is equal to 1 and the value of y is equal to 1. Please take note. So let's replace this here. That means our dy over ds will be equal to, let's replace the values here. This will be remember, this is going to be minus 12s squared first. Let's open this bracket first. Minus 4sy minus 3 over 2s squared minus 12y. So let's replace the values. When you replace the values, this will be minus 12 into 1 all squared minus 4 into 1 into 1 minus 3 over 2 into 1 all squared minus 12 into 1. So when you simplify it, I will have this to be, class, minus 12, that is 1 all square will give us 1. 1 times minus 12 is minus 12, minus 4. 4 times 1 give us 4, minus 3. That is this 3 here. Please take note of that. Over 2 minus 12. So now let's simplify everything here. That is minus 12 minus 4 minus 3 will give us minus 19. While at the denominator here, 2 minus 12 will give us minus 10. When you do that, we have something like this, class. Dy over ds will be equal to, class, minus 19 over minus 10. So this minus at the numerator will cancel the minus at denominator. So I'll be left with 19 over 10. Please take note. So the answer there is option C. Let's solve the next question here, class. Question 3. They said, find the derivative of the function given by y equal to log of s raised to 3 plus 3. Okay, now earlier before now, I told us that whenever you are asked to find the derivative of a particular equation, the first thing to do is to identify the function. Please take notes. Okay, now the function here is logarithmic function, that is logarithm. Please take notes. So the question now is, how do we differentiate logarithmic function? Okay, now before we differentiate this first, let's write solution. All right, so okay, now let's differentiate this. Now this is what you have to understand before we differentiate this. To differentiate any given equation, you have to know the function. Okay, and different functions have their different pattern of differentiation. Please take note, or derivative. So let's know how to differentiate logarithmic function. Okay, now in a logarithmic function, we have natural log and we have exceptional log. So when is a logarithm said to be a natural log? Whenever you have a logarithm to be log of u base 10, log of u base e, log of u, and ln of u. So whenever you have logarithm to be written in this format or to be written in this way, either the first one here, either this or this or this or this. So we call them natural log. Okay. Now, what is the pattern of differentiating natural log here? The derivative of every natural log, the derivative of natural log is equal to differentiate u over original u. Please take note. Okay. Now, this is the pattern to differentiate all natural logarithm. Please take note. Differentiate u. You replace the original u here at the denominator. So what is u? Anything that will stand in this position here is our u. Please take notes. In this position here is our u. Okay. Now let's solve this given question here. Okay. Now we are giving the function to be y equal to log of s raised to 3 plus 3 base 10. Of course, this is one of the natural logarithm. Okay, so let's differentiate this. The y over the s of this will be equal to differentiate u over original u. That is the meaning there. So we have to identify what is standing as u here. This is a part standing as u. So differentiate this. When you do that, we have this to be equal to plus 3s squared plus 0 over, repeat the u. This will be s raised to 3 plus 3. So when you simplify this, I will have this will be 3s squared over s raised to 3 plus 3. This is my answer here. It's very simple. Differentiate u, repeat it at denominator. That means replace the original u at denominator. Differentiate u, replace the original u at denominator parts. Okay. Now let's take the next question here. Question that is question 4. Let's solve this question here. That is question 4. They said a particle 5 gram initially at rest is moved by a force in a straight line such that its velocity v meter per seconds at time t seconds is given by, okay, is given by v equal to 3t squared minus 6t. Calculate the distance traveled in the 5th seconds. Okay, now let's understand the equation perfectly before we solve this here. Okay, they gave us the mass in this question here. The mass is 5 gram. Okay, and the object here is at rest. So if the object is at rest, that means at that point there's a time taking, and that time taking when an object is at rest is t equal to 0. Please take note. That time taken when an object is at rest is t is equal to 0. Please take note. Now the object moved in a straight line, okay, at a particular velocity, and the velocity is v equal to 3t squared minus 6t. We are asked to find the distance. So what is the relationship between solution first? So what is the relationship between distance with velocity, or displacement with velocity? Okay, please, at this point now, velocity, distance, and displacement is the same. Please take note. So we say that velocity v is equal to distance over t. Please take note. If you look into this question here, the velocity is expressed in a variable. That means I will use instantaneous velocity to express the formula. Whenever your parameter is written in variable, that is in parameters, whenever your parameter is written in variable, we use instantaneous motion. Please take note. Now expressing this velocity in instantaneous velocity, that means v will be equal to ds over dt. Please take note of this. But what is given to us here is velocity, and is given to us as 3t squared minus 6t. Please take note. Now they said at rest, that means u is equal to 0, t is equal to 0 at this point. That is t1 is equal to 0, okay? Now they gave us the mass here. The mass is given to us as 5 gram. Change to kg. I will divide this by 1000, so I will have 0.005 kg. Please take note. All right, now the velocity is given to us. Let's replace the velocity here. I will have this to be, replace this velocity, which is given to us as 3t squared minus 6t. So this is going to be 3t squared minus 6t. Please take note. It's equal to ds over dt. Our intention is to make s, that is to find the distance. So let's cross multiply to find the distance here. When you do that, we'll have something like this. D of s is equal to 3t squared minus 6t d of t. So whenever you have derivative in a multiple way, if I have something like this, s ds, so we call this integration. Please take note. Whenever derivative is expressed in a multiple way in this form here, is called integration. So that means this is called integration, and this is also called integration. So expressing the elongated s, this is going to be integral of the s is equal to integral of 3t squared minus 6t dt. Now the boundary, that is the time taken here, for t1 is 0, while for t naught is 0, while for t1 is 5. Okay, the reason for this 5 is from the equation. They said calculate the distance traveled in the 5th seconds. So the second t is 5 seconds. Please take note. So now let's integrate here. If you integrate this, the s, I will have s. Okay. If you integrate this here, if I integrate only this is going to be s. The reason is this can also be expressed as this part here, class, can also be expressed as integral of s. We are using s because we are the Later I'm integrating with its s. Integral of s raised to the power of 0. This part here can be expressed as integral of s raised to the power of 0 ds. Now I'm using s because I'm integrating with respect to s, okay? So s raised to the power of 0 is 1. 1 times the s will give us the s. So the pattern of integration, the linear pattern of integration is to add 1 to the power and divide by the new power. Please take note. So add 1 to this power here. So I'm going to have s raised to the power of 0 plus 1. So I'm going to have this to be s raised to the power of 0 plus 1 divided by 1. So I've integrated the left hand side, that is this part here. I will have this is equal to, now let's integrate this. Remember, you add 1 to this power, you divide by the new power. So this is going to be 3 t raised to the power of 2 plus 1 over 2 plus 1 minus, there's an invisible one here. Do the same thing, 6 t raised to the power of 1 plus 1 over 1 plus 1. The boundary of this is 5 at the top and 0 at the bottom, okay? I'm going to explain this interval here. This is called interval. That is the highest interval and the lowest interval, okay? Now let's simplify the left hand side and also simplify the right hand side, okay? When you do that, we have some s is equal to 3t raised to the power of 3 divided by 3 minus 6t raised to the power of 2 divided by 2, or in the boundary of 0 as lower boundary, 5 as upper boundary. So if you cancel, this can cancel this 3 can cancel this, 2 go here is 1, 2 go here is 3. So when you do that, our distance will be equal to t raised to the power of 3 minus 3t raised to the power of 2, or in the boundary of 0 and then 5. Whenever you have a boundary like this, what does it mean in integration? It means um, um, upper band minus lower band. That means with the same expression here, you replace your upper band minus, with the same expression here, you also replace the value of the lower band. So the value of the upper band is 5, while the value of the lower band is 0, okay? Now let's replace the value here. When you do that, we have our distance to be equal to, class. For upper band is 5, replacing t as 5, 5 raised to the power of 3 minus 3 into 5 raised to the power of 2. So minus the lower band is replace t as 0. So I will have 0 raised to the power of 3 minus 3 into 0 raised to the power of 2. So class, 5 raised to the power of 3, I will have 1, 2, 5 minus 5 raised to the power of 2 is 25. 3 times 25, I will have this to be 75. Please take note of this. Minus 0 raised to the power of 3 is 0. Minus 0 raised to the power of 2 will be 0 times 3 will be 0. Please take note. So this will be off. That is 0 minus 0 will be off, okay? So let's simplify this. 125 minus 75 will give us 50. So our distance here is equal to 50 in meters. This is our answer here, okay? Now let's solve the next question here. That is the next question here, question 5. Let's solve this question here, question 5. They said the distance s meters. The distance s meters a particle covers in t seconds is given by s equal to 3 over 2 t squared minus 3t. Determine the acceleration of the particle. So we are giving options here, okay? Now let's understand the question perfectly. The distance here is given to us in variable, and we're asked to determine the acceleration. Okay, now whenever a parameter is given to you in variable, to determine velocity or acceleration, we use um, instantaneous motion. So what is the formula to solve for instantaneous formula for acceleration? Well, listen to me carefully. Before you determine instantaneous acceleration, you have to find, or you have to calculate for instantaneous velocity. Let's solve this first. Solution first, please. So let's solve for the acceleration here. Our acceleration, that is instantaneous acceleration A, is equal to dv over dt. So I have to calculate for velocity. So how do we calculate for velocity? Instantaneous velocity is equal to ds over dt. Please take note. So let's find instantaneous velocity before we calculate for instantaneous acceleration. Okay, now let's find instantaneous velocity. That is v is equal to ds over dt, and this can also be written as d over dt of s. Just the same way, if you have 2 over 3, this can be expressed as 1 over 3 times 2. Please take note. Now, if you look into the question carefully, the distance is given to us. The distance is given to us as 3 over 2t squared minus 3t. So that means when you do that, this will be v is equal to d over dt into distance is 3 over 2t squared minus 3t. So what does this expression telling us here? It means that we should differentiate this expression here. That's what it means. D of dt of 3 over 2t squared minus 3t simply means differentiate this. And when you differentiate this symbol of d over dt will not be here again. Please take note. So let's differentiate. Take this power here down to the base and subtract 1 from it. I'm going to have this to the class. Differentiate this. I'm going to have take the power down to the base. I'll have 2 of 3 over 2. Subtract 1 from it. This is going to be 2 t of 2 minus 1 minus this. Do the same thing here. I will have this to be 1 times 3 of t raised to the power of 1 minus 1. So this is how we differentiate any function that is of this pattern here that we have whenever you have one digit, a letter, and a power. So to differentiate that, you take the power down to the base, you subtract 1 from it. So this we cancel this. I'll be left with 3t minus 3 minus 3. So we have calculated for the velocity here. But if you look into the question, we are not asked to find the velocity here. We are asked to find acceleration. And what is the formula for acceleration when the parameter is written in variable? So our acceleration A will be equal to dv over dt, and this is the same thing as d over dt into v. Okay, so our v is given to us as this. When you replace the value of v, I will have this to be d over dt into 3t minus 3. What does it mean here? It means that I should differentiate. What does it mean here? I should differentiate this. Please take note. So it means that we should differentiate this. That is d over dt of 3t minus 3 means differentiate this. Now when you differentiate this, we are going to have this to be 3 in meter per second square. So this is my answer here. Whenever you have d over dt, it means differentiate the function this. So whenever you differentiate this function this symbol of d over dt will not be there again. Please take note. So I'm going to have